Welcome back everybody. So I'm Dave and today we're going to look at the power rule, part of differential calculus. So when we are differentiating an expression that has an x in it, that is the variable, what we do is we multiply through by the power and then we subtract 1 away from that power. Let's see this in two examples below. Let f of x equal 5x cubed plus half x squared minus x plus 1 and find f prime of x. So this expression here is telling us that we have to differentiate this function of x with respect to x. So let's go and do that now. So f prime of x, which is known as the derivative of f, will be timesing by the power and then taking 1 off the power. This would result in 15x squared. The next part of this expression, this function, is half x squared. So when we times through by 2, the half will turn into a 1, and then when we take 1 off 2, we will get 1. Now if you remember, anything to the power of 1, we wouldn't normally write the 1 at the top, so therefore just leaving us with plus x. This expression here, this minus x, at the moment the power is 1. So when we times through by the power, we'll be timesing through by 1. But this 1 now will reduce down, when we take 1 away from it, we'll go to 0. And remember that anything to the power of 0 is just 1. So therefore then, this will actually just become negative 1. The x's will now go because it is to the power of 0, and anything to the power of 0 is 1. The constant actually has no x associated with it, so it will disappear. If you think of it as like being 1x to the 0, you can still perform the power rule like timesing through by 0, but the moment you get to that stage, the whole expression will disappear as you're timesing through by 0. The quick way of thinking about this is just all constants will disappear when you are differentiating. So there we go. That is the first question solved, finding f prime of x. Let's go down to this one, question 2. I've put a few more tricky elements into this. First of all, I've called the function y. That is because in the question, they may refer to it as y or f of x. In this one here, I've just changed it to y. And this expression here on the right here is dy by dx. It just means find the derivative of y with respect to x. Stage 1 of this is to write this in index form, so in indices form. So this root x is x to the half. That is part of the indices unit and number work. You'll need to look back over that if you are unsure. This here is written as 3 times x to the minus 2. Again, another indice rule, but we need to get this expression in power form before we can actually do the differentiation on it. That is whole idea. We get it into power form and then we can perform the power rule on it. So let's go ahead now and find dy by dx. Okay, this could also be known as y prime. Okay, y prime or dy by dx. Let's times by the power, that's a half. Taking 1 off the power would make that minus half. Half subtract 1 is negative half. Now on this next expression here, we are going to times by the power. So that would make that positive 6. Then we are going to take 1 away from that power. Don't forget, when you're minusing 1, you're going further down the number line, not back towards 0. So minus 2 subtract 1 is minus 3. There we go. And if for any reason they ask you to rewrite this without any negative indices here, you would have to reverse those indice operations. So you would have a half and then 1 over root x plus 6 over x cubed. Now that step there in orange is not necessarily like, you don't have to do that unless it asks you to. But sometimes it's easier if you have to substitute a number into this step to find the gradient. So I actually quite like doing that as a sort of a habit, but it's not absolutely necessary. Okay, thanks for tuning in. Don't forget to like and subscribe to the channel. When new content drops, you'll be the first to know about it. On the left, click the video for more tutorials. I'll see you next time.